All right, Algebra 1B students, welcome to part 3 of lesson 7-8 on geometric sequences. Okay, we just have one more little piece of this section we need to deal with before we finish up chapter 7 and get ready to review before our test next week. Now, just as another reminder, a geometric sequence is one where the ratio of any term to the one before it is the same, meaning we're multiplying over and over repeatedly to get from one term to the next term. All right. Now, we're going to begin on page 469 and look at problem 4. This is the last type of example we need to be able to do before we finish up this section. All right. It tells us we can represent a sequence using function notation, meaning we're going to talk about a geometric sequence as a function in this video. And this allows us to plot the sequence using points where we pick a term number, and then the value of that term is our x and our y values. N is the term number, and a sub n is the value of that term. Okay? So let's look at an example of how we can look at a geometric sequence as an exponential function. All right? For example, we have a geometric sequence here that has an initial value of 6, and it has a common ratio of 2. We are asked here to write a function to represent that sequence and then graph it as well. All right? Now, this is all going to begin with our explicit formula, which remember was our one-time formula where we have a sub n, or our nth term, equal to a sub 1 times r to the n minus 1 power. So we can easily put in 6 for our a1 value, our initial value, our starting point, and 2 for our common ratio, or our r value. All right? Now, if you look in the next line, they've just turned this into a function with x and f of x instead of a sequence with n and a sub n. So we substitute our a sub n for f of x. This is like our y value. And we substitute our n here in the exponent for an x. So we now have f of x, or our y values, equals 6 times 2. We know that's our initial value and our common ratio, times 6 times 2 to the power x minus 1, where x is our x value that we want to plug in here. So to summarize this, the function f of x is equal to 6 times 2 to the x minus 1 power is a function that represents that geometric sequence. All right? So if we want to graph that function, then we just need to make a table of values, and then we'll graph it. Okay? So to begin, if x is equal to 1, x equals 1, that means we're right here. F of x, f of 1 is equal to 6 times 2 to the 1 minus 1. Now, 1 minus 1, we know is equal to 0. So this is 6 times 2 to the 0, which is, well, that's 6 times 1, which equals 6. If x equals 2, then I have 6 times 2. Now my x value is 2, so I'm going to the 2 minus 1 power. That means 6 times 2 to the 1 power, which just equals 6 times 2, which equals 12. If x equals 3, I now have 6 times 2 to the 3 minus 1 power. That's the same as 6 times 2 to the second power, which equals 6 times 4, which is equal to 24. And then one more time, if x equals 4, my geometric sequence function, f of 4, is 6 times 2 to the 4 minus 1, which really is 6 times 2 to the third, which equals 6 times 8, which is 48. So now I've got these coordinate points. Here's an x value and a y value, x value, y value, x value, y value, x value, y value. All right, so I'm going to plot those 4 points and connect them in a line as an exponential function. All right. So I know my first point was when x was equal to 1, my value was 6. Now I'm going to go by 6's here, so this is going to be 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Okay? So when my x value equals 1, my y value is equal to 6 up there. So that's right here, 1 and 6. When my x value is 2, my y value was 12, so that's going to be right there. 2 in the x, 1, 2, and 12 in the y. And then 3, my y value up there was 24. So I'm going to go to 3 in the x and 24 in the y. And then finally I'm going to go to 4 in the x and 48 in the y, which is all the way up here. Okay, so here now is my function. And of course we can continue it the other way as well. Okay. There's my exponential function that represents this geometric sequence. Right? My y values in this case are my geometric sequence. 6, 12, 24, 48, and so on, and so on, and so on. Right? Dot, dot, dot. Okay? So this function here represents that geometric sequence. Now I would like you to write a function and graph a function that represents a geometric sequence with an initial value of 2 and a common ratio of 3. Okay, so follow the steps that we looked at before, or follow the steps that they have for you on page 469 in problem 4. Okay, this is on page 469. And once you master this problem, you are ready for your practice problem set. That's all I have for you tonight. Have a great night. I will see you tomorrow.